dioxide, which is an additional carbon dioxide which gets accumulated in the Earth's atmosphere. Carbon dioxide is what is called as a greenhouse gas. These are it's just one of the several gases which play this role. So what happens is the planet Earth has an atmosphere which has a certain composition, and the solar radiation reaches the Earth's surface through the atmosphere. So the radiation is coming through the atmosphere. On the surface it gets absorbed, and what is radiated by the various objects on Earth is basically heat. And greenhouse gases are those molecules in the atmosphere which hold that heat. That heat gets trapped in the atmosphere because of these gases. So carbon dioxide is the major one, but there are other gases also which we'll talk about in some time. This effect is called greenhouse effect, and it is actually a useful effect in the sense that it is because of this trapped heat that the Earth is a warm planet, and life has evolved on this planet. So in a sense, greenhouse effect is why we exist on Earth. But now what has happened is, because we have been putting this additional carbon dioxide into the Earth's atmosphere through digging out and burning fossil fuels, more heat is getting trapped than what we need. So things are now becoming uncomfortable. What are the outcomes of this and why this has become a crisis is what we'll talk about. So before the industrial era, that is before people started using coal and petroleum in such a large quantities, the natural percentage of carbon dioxide in the atmosphere was 280 ppm. ppm is parts per million. If you took the entire atmosphere and divided it into 1 million parts, out of that only 280 parts was carbon dioxide. Because of the additional carbon dioxide that human activity is putting into the atmosphere, by 2000s we had already increased this amount of carbon dioxide in the atmosphere by 100 ppm. So we are currently actually at more than 400 ppm in 2021. Researchers believe that if we continue to use fossil fuels in this same fashion, without, I mean, every year the use of coal and petroleum has gone on increasing over the last so many decades. If that increase continues, then by 2100 we will have about 900 parts per million carbon dioxide in the atmosphere. So it will be more than triple from what it was in the pre-industrial era. And carbon dioxide, as I said, is not the only greenhouse gas. There are other gases also that our activities are putting into the atmosphere. I have just given examples of three major greenhouse gases here. One is methane. Methane is produced in natural phenomena, and also it is produced in some industrial processes. A methane molecule lives as a methane molecule in the atmosphere for about 12 years. But if you have put 1 kilogram methane into the atmosphere today, over the period of next 100 years, the warming that will be caused by methane, the heat that will be trapped by this 1 kilogram methane, will be 28 times more than the heat that would be trapped if instead of methane we had put in 1 kilogram of carbon dioxide. So in other words, methane is 28 times more powerful in trapping heat than carbon dioxide. So GWP is global warming potential over a period of 100 years. That is what that term GWP 100 years means. So it is basically telling you that methane is 28 times more dangerous than carbon dioxide. Nitrous oxide is also a pollutant which is produced in various industrial processes. A nitrous oxide will live in the atmosphere for 121 years, and over a 100-year period it is 265 times more dangerous than carbon dioxide. Hydrofluorocarbons, these are chemicals which were introduced as a substitute to chlorofluorocarbons. I'm sure everyone has heard about CFC or chlorofluorocarbon. These are the chemicals which were causing holes in the ozone layer. So HFCs were introduced in order to replace CFC and solve the ozone layer problem. But HFC is a greenhouse gas. So in solving one problem, we have added to another problem. And HFCs have a global warming potential which is more than 1,000 times that of carbon dioxide. So these are just some of the additional pollutants which human industrial activities are producing, and these also add on to the effect of carbon dioxide. So carbon dioxide has increased by 100 or nearly 150 ppm by now. In addition to that, these pollutants have also come in. So this is the reason why everybody is now more concerned about climate change, because before the industrial era, the average temperature of our planet was 14 degrees centigrade, and that is the ideal temperature for life to exist on Earth. But because of this increase in greenhouse gases, we have already increased this temperature by 1 degree centigrade. And if we actually keep on doing industrial activity relying on fossil energy the way we are doing now, if we just continue to do that, if we keep on expanding this, then by the end of this century, which is not very far off, it's just 80 years from now, the average temperature of the planet will be 18 degree centigrade. So what does this mean? I mean, during our 1 year cycle, we see more temperature variation than this. So why is everybody bothered about 1 degree, 2 degree, etc.? So this is because this is the average temperature of the planet. This is not the temperature of any location. So think about it this way, that you take the average annual temperature of Pune, you take the average annual temperature of say Delhi, of New York, of Tokyo, of Johannesburg, of Sydney. You go to different parts of the world and take average annual temperature of various locations on the planet, and then you take the average of these averages. That is the number that we are talking about here. So this is not the temperature of any location as such. It is an indicator what is the on an average temperature of the entire planet. And if that is increasing, then a lot of things are changing. What is changing, we'll talk about that in a minute. So it's not that people are just standing by and watching this problem increase. Since 1990s, there have been internationally discussions on how to deal with this problem. And we already made one effort to do that in early 2000s, which didn't succeed. So in 2015, majority of the countries in the world came together and decided that we will all work together to limit the increase in the temperature of the planet to not more than 16 degrees centigrade. So this agreement was signed in Paris, and therefore this is called Paris Agreement. So by 2100, according to the goal set by the Paris Agreement, we should not allow the temperature of the planet to increase beyond about 15.5 to 16 degrees centigrade. So basically we need to slow down the global warming. Now, why specifically this range? For two reasons. One is that you need to set goals which are realistic. Now, climate change is a phenomenon which cannot be reversed. So you cannot cool the planet. So the only thing now that you can do is you can try to slow down the increase in temperature. So this 15.5 to 16 degrees centigrade is achievable, it's doable. And the second reason is that if the temperature goes beyond 16 degrees centigrade and starts approaching 18 degrees centigrade, then the impacts will be so big that it will practically collapse the entire human civilization. So this is sort of the you can say convenient safe limit, something which can be achieved. There is going to be damage, but that damage will be something that we can cope with, we can recover from. So this is the goal that countries of the world have set for themselves. Now, in order to I mean, you can control something that you can measure. So this temperature thing is difficult to measure because this is the global average that we are talking about here. So it's difficult to say that, okay, if I used some coal-based electricity here today, how much warming that is going to cause for the entire planet. That's a bit difficult to calculate and to relate with. Therefore, this very useful concept was introduced in the 1990s, which is called carbon footprint. So carbon footprint is a calculation process which allows you to estimate what is the total greenhouse gas emissions in a process or an annual cycle. So you can find the greenhouse gas emissions of, let's say, manufacturing your cell phone, or you can find the greenhouse gas emissions of your own living for 1 year. So that's the annual cycle. This is all the greenhouse gas emissions taken together collectively. And as we saw just now, different gases produce different amount of warming. So you need to scale all these gases to a uniform scale. So this is something like your currency exchange. If you have a few dollars, you have a few rupees, if you have a few yen, and you want to find out how much total money you have, you convert all the currencies into one, and then you can do the addition. So something similar is done here. Everything is converted in terms of tons of carbon dioxide equivalent, and then it is added up. So that is why the unit of carbon footprint is tons of carbon dioxide equivalent. And that's why we keep talking about carbon dioxide, carbon emissions, etc. But the way this is calculated, all the greenhouse gases are being taken into account. So that's important to remember. So this is where the concept of carbon footprint comes from, and we are going to see in some time how you can actually measure the carbon footprint of your own lifestyle using your own data. Where are these greenhouse gas emissions coming from? So let's say we found out our carbon footprint, and what do we do with it? So we need to know the sources of the emissions so that we can figure out how do we reduce our carbon footprint. So the sources are basically all the energy that we use. Electricity, because in spite of the increase in renewable energy installations over the last couple of decades, even now majority of the electricity in the world, including in India, is produced by burning mineral coal. So every time we use electricity, we are then essentially using coal, and therefore we are causing greenhouse gas emissions. Mineral coal in itself is an industrial fuel. So wherever coal is directly used, it is causing greenhouse gas emissions. We ourselves use petrol, diesel, kerosene, a variety of petroleum fuels, and therefore we are causing GHG emissions. We use natural gas, LPG, for cooking, for transportation. So all, I mean, solid, liquid, gaseous type of fossil fuels, every time we use them either directly or in the form of electricity, we are causing greenhouse gas emissions. But apart from that, there are also other things to consider here. For example, think about the house that you are living in. In order to construct the house, energy has been spent. Your house consists of mainly cement and steel, which are two of the most energy intensive materials that humans produce. So if you are living in the house, the greenhouse gas emissions which were caused in building the house are your emissions. So you have to take responsibility of those. Similarly, the food that we eat, it is grown by spending energy, it is transported by spending energy, it is cooked by spending energy. So there is a lot of energy that is involved in the food that we eat. All the furniture that we use, all the electronic devices that we use, all the products and services that we use are consuming energy in order to provide us with those conveniences, and therefore all of those also count as GHG emissions of the end user, of the end beneficiary. So in addition to direct energy consumption, there are also indirect or embedded energy consumptions which are also leading to greenhouse gas emissions, and all of this needs to be accounted when we want to calculate our carbon footprint. Now, why is there so much concern about this warming of the planet? The increase in the average temperature of the planet is causing melting of the polar ice caps and glaciers elsewhere. All of this water ultimately ends up in the sea. A lot of heat from the atmosphere is also getting absorbed by the oceans. So the water is also expanding. So because of these two effects, there is additional water coming in and water is expanding, sea level is rising. That means a lot of land is going to be submerged under oceans. As it is, the planet has 70% sea and only 30% land. Out of that 30%, more land will go underwater. But more drastic than that is that the warming of the ocean is going to play havoc with the weather engine of the planet Earth. Formation of clouds is getting impacted. As a result, the entire rain cycle is getting impacted, and as a consequence of that, even the summer and winter temperature ranges, humidity, everything is going for a toss. So this disruption of weather has many consequences. It causes droughts and floods where those kind of conditions had never been experienced before. There is drop in agricultural yield. We are now seeing more natural disasters. Just now we have seen a cyclone on the west coast. Now west coast of India generally doesn't get cyclones. Cyclones only come on the east coast. But last year we saw a cyclone which had come after 100 years, and then again this year we have seen a cyclone even before onset of monsoon. So it's quite likely that a couple of more cyclones will be formed in the Arabian Sea before we get to September, October. So that is direct evidence that we are now seeing more natural disasters, and even the East Coast cyclones are becoming more frequent and more severe. There is another cyclone that is now coming, but that's on the coast of Odisha. It's on the eastern side. So if both the coasts are going to be alternately hammered by cyclones, that's really going to be bad for us, because we saw that even though the cyclone was on the coast, even as far back as Pune, we have seen rain and windy conditions and stormy conditions. So similarly, we have experienced that whenever there is a storm in the east coast, even inland, for many locations there is a lot of rain and storms. So these do not remain only coastal disasters, but they do have impacts elsewhere too. Because of the changes in the weather conditions, now disease-carrying pathogens are traveling in new territories. So there are unexpected health impacts because of that. So on one hand, because of biodiversity loss, we are seeing a lot of new diseases. Right now we are in the middle of a pandemic because of a new disease. But in addition to that, old diseases entering new territories can also be very devastating, because people living in those territories have never encountered those diseases. So for them, it is as good as having a new disease come in. So this is also another problem. And overall, because of all of this, extinction of species is also getting accelerated. So there are widespread, multi-pronged impacts of climate change, and that is the reason why it is said that this is now the most important or the biggest crisis that human civilization is facing. In the Indian context, this becomes even more of a challenge, because we are in a unique problematic situation. On one hand, we are the third largest emitter of greenhouse gases as a country at this point in time. And at the same time, we are among the top 5 countries which are going to be most impacted by climate change. So typically, countries which are emitting a lot of greenhouse gases are not getting impacted by climate change. The countries which are getting impacted by climate change are not the ones who are contributing to the problem. But India is one of those few countries where we are both the villain as well as the victim of this problem. But there is another sort of finer nuance to this. Who is the emitter and who is going to face the biggest disasters? So typically it is the urban people, well-to-do people, upper middle class and higher, whose energy consumption is higher, and therefore they are the ones whose greenhouse gas emissions are contributing to the climate change problem. On the other hand, who is going to be impacted the most? People who live in close vicinity of natural systems, rural people, tribals, and also urban poor, these are going to be impacted the most. So this, in a way, to give you an analogy, because all of us have experienced this, how did this COVID-19 pandemic came to India? It came through international travelers. But what was a biggest consequence of this? One consequence was the countrywide lockdown, and that led to all the urban migrants to walk back to their homes. So the lockdown impacted the poor the most, whereas the disease was brought in by those who could afford to travel by air to other countries. So that's sort of similar to what is happening with climate change. So the reason I'm making this point is that you have to realize that climate change is not just an environmental problem. It is a social justice problem, and it has to be looked at from that angle also. And therefore, one cannot very simplistically say that you bring in some fancy new technology and that will solve the problem. It's not going to work like that. I'm making this point specifically because I'm talking to engineering students. Technology will be an important tool in dealing with climate change, but unless we address the social justice aspect of climate change, we will not solve this crisis properly. So it's important to keep that in mind. So what then should we do? I mean, especially in the Indian context, how do we define climate friendliness, and what are the steps that we should take in order to make ourselves sort of survive this crisis and also defeat this crisis. So there is a 4-point formula that we can adopt. Reducing fossil fuel use, sequestering carbon, adapting to changes, and building resilience. Let me explain each of these briefly. Reducing fossil fuel use, you may think that, okay, I'm talking here about instead of using fossil fuels, let's use renewable energy or something like that. Yes, that is part of it. But that will work only if first we examine how and what energy we are using and what are we using it for. Because of the abundance of fossil fuels, we have had the luxury of being extravagant in our energy use. We are using energy in a very inefficient and wasteful manner. We are also using energy to satisfy a lot of greed if we have the money to buy extra energy. And at the same time, there are a lot of people who are not even getting energy to meet their basic needs. So the first thing that needs to be done is to relook at how we are using energy, how is the energy access distributed across the world, and correct those inequalities. Also, all of us will have to change our mindset and decide to give up on our greed and focus on meeting everybody's needs. If we do that, then the global energy requirement itself will reduce. And that will make the transition from fossil fuels to renewable energy easier and possible. Right now, many people claim that removing carbon dioxide from the environment, let nature do it in the best way that she knows, with minimum interference from our side. At the same time, there are some technologies that are now coming up which are claiming to remove carbon dioxide from the atmosphere, but it remains to be seen how technologically and financially viable those processes will be. Adapting to changes is another important thing. As I said, some temperature increase is now unavoidable, which means that some of the climate change impacts are going to happen, are already happening. So we need to learn to live with them. So now, for example, on the west coast, if every year cyclones are going to come, then cities like Mumbai have to really rethink some of their huge big infrastructure projects that are being planned around the coast of Mumbai. Or the farmers in Konkan have to rethink how they are going to change the way they do their farming, because currently their farming is based on trees, and trees take a long time to grow, and one storm can totally destroy your tree plantation. So mango farmers may have to shift to other crops if they want to continue earning money. So this is adapting to changes. Building resilience is about how fast you recover when you are hit by a disaster. So how good are our response systems so that we firstly minimize damage to people as well as to infrastructure, and secondly, how quickly and how efficiently we build back. That is what resilience is all about, and we do need to do a lot of work on those systems also. So this is the overall sort of path forward that we have to take if we want to deal with the climate crisis. Now, in this journey, the journey has to start from individuals, but it cannot stop there. So as individuals, you start this journey, but then you have to have this big picture in mind, and you will also have to then look at what can be done at a community scale, at your institutional scale, at the governance scale, and so on. But the first step in this journey is to measure and then reduce, if required, your personal and family carbon footprint. For that, we have designed a carbon footprint calculator, which is available as a web app. And in a minute, I'll hand over to Purnima to take you through this web app. But before that, let me just quickly show you what are the various things that we do through Samuchit Envirotech. For individuals, we have this carbon footprint calculator. At community level, we are conducting a number of online and offline events. We also have discussion groups on urban sustainability in social media. So anybody who is interested in these issues can connect with me and participate in these. For institutions and businesses, we offer a variety of consultancy services for carbon accounting, green accounting, vulnerability assessments, risk assessments, and so on. We also provide consultancy to CSR projects. And for professionals, some of you might be interested in this, we do offer an online course on basic carbon accounting. As climate change is evolving as a crisis and as solutions are coming up, it's becoming more and more essential for businesses, institutions to measure and report their carbon emissions, their institutional or organizational carbon footprints. So a lot of people will be needed in the next 10 to 15 years who will know how to do carbon accounting. So this is a new career opportunity that is opening out, and from that point of view, we have designed this course. We are also in the process of creating a number of other educational inputs for urban sustainability, and we also offer internships in these fields. So any of you, if you are interested in some summer internship, you can get in touch with me. So now we want to look at how to use the personal carbon footprint calculator, and for that we will take one example, and so this is a typical family, and Purnima will take you through this. But I just want to mention this before I stop talking, that you are talking about project-based learning. So what we are going to show you is a tool around which you can build various interesting projects. So some students can take this tool and calculate the carbon footprint of all the students in the college, and then some analysis can be done as to what is the carbon footprint of the engineering student community, and what can the students then do, what changes they can make in order to reduce their carbon footprint. Or some students can take up this tool and do the analysis for, let's say, 50 to 100 people in the city, in the community that they are in right now, because I'm sure since everybody is learning online, you are all sitting in different places around the country. So one can make use of that opportunity and get data of typical upper middle class urban families across India, and on that basis the students can do an analysis and come up with recommendations as to how should urbanites in India should change their way of life to reduce their impact on climate change. So there are number of ways in which you can use this tool. So with that, I hand over to Purnima. Purnima is an environmental scientist and has been working with me for quite a few years now. And she is more tech savvy than me, so I'm roping her in to do the demonstration of the calculator. Over to you, Purnima.
Okay. Thank you, Dr. Karve. And I may be tech savvy, but then this carbon calculator has been designed by Dr. Karve. So, okay, and thank you, PVG, for hosting us here. Okay. So I'll quickly jump into this example. So we are talking about a typical urban Indian family here, where we have 4 members in the family. Then their house, they live in a house having 1500 square feet as the floor area, and the way they manage their organic waste is by giving it to the local municipal system that they have. So the local, like the way most of us do, we do have a local system, and we tend to give the waste to them directly. So the similar way, this family also has the same, does the same thing. Then their monthly electricity consumption is 500 units. So in order to use the calculator, we need the units. Like we need to know this information. That's why we have mentioned here the units. And when you want to calculate for your footprint, you will need a electricity bill. So which is handy, or else you can it becomes easier for you to add the numbers. And we have also given the information about a common electricity consumption of this family. So here they live in a society of 9 apartments, and their common services bill, like the electricity consumption, is around 1500 units. We'll just see how we are going to use this information in a moment. Then for cooking fuel, they are using LPG cylinder, and that lasts for around 2 months. Then for transport related emissions, we have mentioned here that they have 2 vehicles. One is a petrol fueled vehicle having a mileage of 40 kilometers per liter, and daily it runs around 15 kilometers. Then the next vehicle that they have is a 4-wheeler. It is diesel fueled, and the mileage is 12 kilometers per liter, and it runs around 60 kilometers daily. The 2-wheeler is used by 1 person, and 4-wheeler is used by 2 people, one of which is the family member. And this is the information about their air travel, which for a recreational purpose. So they went to a vacation from Pune to Bangalore in economy class, and there was no carbon offsetting. So we'll see how we are going to use this information. So the idea of giving this example is also to give you a thing that this is the basic information we need while using the calculator. It is fairly simple to use, and anybody can get to know their footprint. So I'll just I have that the link that is given in the presentation. We can also share that with you, and I have added that in my browser. I'll just share my screen.
Yeah, I hope I can stop sharing.
Okay. Yeah, I think it is gone.
Have I stopped sharing?
I think so, because we can't see your screen now.
Okay, great. Go ahead.
Okay, I just share. Okay.
Yeah, it's visible.
Is visible? Okay.
Yeah.
Okay. So once you click on the link, you can see that we have given here the basic information about what is carbon footprint and what does it mean by direct emissions and indirect emissions, and then how in 4 simple steps you can get to know your footprint. So you just say submit for calculation here, and then you will come to this page where you have to add your information. It is just for documentation. This information is not going to be used anywhere. So you can fill up your name, email address. Right now I'm just putting my details. So when you're doing a survey or something, this information becomes important, because at the back end then we can track the people for whom you have taken the survey, and then you can also do some analysis. So that's the reason why we are collecting this information. Okay. So this is the step 2, where we are going to add household details and the electricity information that for the family that we have given. So as per the example, this family has 4 people in their 4 members. So we add the number here. Total number of persons in the family is 4. Then we have given information about the floor area, the carpet area of the house. So we'll add that 1500 square feet. We need information in square feet, so that needs to be added here. And then how they are managing their organic waste. That also information we have given. So if it is a municipal garbage collection system or garbage dump, we say yes. Otherwise, we can say no. So here it is like now that we know about the emissions that are generated through organic waste. That is the reason why we are talking about specifically about organic waste. And it is also easy to manage at source or in your house itself. So a lot of people do ensure that no wet waste goes out of their house. So they may be doing, they may be generating biogas using the household waste, or they may be composting, or they may be simply using it using it in their terrace garden or something. So the idea is not to let the organic waste go out of your house, so that you don't contribute to those landfill emissions. So here in this case, this family is sending it out to municipal garbage collection system. So we say yes. This information was about household details. Now we go to the electricity part. So here it is mentioned that you can refer to your electricity bill, because the number of units that is mentioned only in the bill. So it becomes easier. So it will be good if you have your electricity bill handy. So in case of this family, we know that they are using their monthly consumption is 500 units. Then especially for this tariff, the tariff is given behind your electricity bill. Like it depends on the number of the amount of your usage. So if you are using between 0 to 100 units, the per unit rate is different. And if it is more than that, then the rate increases based on the unit consumption. So that's why it's better to have a bill. So right now we are just assuming here that it to be 5 rupees per unit, since the units are 500. So yeah, I was talking about the information related to common services or shared electric services about the family. So that information we have here. How much are they paying for, like how much units are being consumed when they're using the shared services. Like you have the lights in your parking areas, something, that kind of thing. So for that also you are paying some money for the electricity, for the common electricity bill. So in case if that information is available with you, you can say yes and then fill up this information. If you don't have that information, it's okay. You can simply say no and go ahead with the calculation. So since we have the information about this family, we'll add that common monthly electricity use. So we know it was about 1500 units, and the number of households in the society sharing this common facility, it is 9. And then the tariff. So as I mentioned, the tariff will increase with the increase in the units. So here we can take as 7 rupees per unit, or maybe 8 rupees per unit, since the units are higher here. So once you add this information, you can see that here some numbers occur here. So these are annual carbon emissions and the cost related to the electricity, to the emissions. So once you see the numbers here, you can just click on submit total units value, and then you see a pop-up saying that this data has been saved successfully. Can you see the pop-up? I guess you should be able to see. So you just say OK for that pop-up and you go to the next.
Yeah, the pop-up is visible.
Visible. Okay. So step 3 is about adding information related to cooking energy that you're using. So we have two options here. One is for LPG gas cylinder, which most of us use, or we also have the piped natural gas now. So a lot of families do have this the PNG now. So you can add the data related to any of them. So in case of this family, it is LPG. So we just say yes here, and then you can see this is the information that you have to add here. So the average number of days you are using the cylinder. So here it was 2 months, that is 60 days. And then the price of LPG cylinder, which is non-subsidized. So that is I think 600. No, I think so. This can be more
non-subsidized is
than
nearly 100.
1,000. Yeah,
Yeah.
1,000. Yes, yes, yes. So yeah, or it can be more also, but right now we are just considering 1,000. Then the price of subsidized LPG, that is I think around 700 to 800 rupees now, maybe more. So we're just considering here 700. And the annual quota of cylinders that we have, that is 12. And once you add this information again, you can see some numbers occur here, which means that your data has been saved. But before that, I'll just quickly also show you what do we need in case of the piped natural gas cooking fuel. So you just say yes here, and then you can see two tabs here. This information you can easily get it from your MNGL bill. So generally it is a bi-monthly bill. So you can just see that bill, and here you can write the consumption, the monthly the consumption of piped gas. So that's in I think BCM. So you can add that number here, and the price that you are paying per unit rate is also given in the bill. So you can simply add that, and then you get you can just simply submit that cooking energy details. So I just say no right now, and then you get this pop-up about details saved successfully. Just say okay. Go to next. Yeah. So the next step and the last step is about adding data related to your travel. So here the idea is to give information about only your daily commute and personal commute, basically, which is not which you are not doing it for somebody. Like for if it is like for in case of air travel, if it is about your work related air travel, that information we won't add here. But if you are going with your family or for some recreational purpose, if you are traveling, then that information we can add here. So in case of this family, we know that they have 2 vehicles. So firstly, we have to mention the number of vehicles for which we are going to add data. So in this case, we know it's 2, so we add 2. But in case you have more than 2 vehicles, so the vehicles and if it is too much for you to add all the data, then you can decide. You can say that whichever vehicle you are using the most for daily travel, maybe you can add information only for those vehicles, maybe 1 4-wheeler and 2-wheeler, something like that. Or if you want, you can add, obviously you can add data for all the vehicles that you are using for your daily commute. So it's but you need to mention the number of vehicles here before doing this calculation and say submit, so that it gets recorded that two times we are going to add the data, or maybe 4 times or something like that. Then yeah, we'll start adding the data. So the first vehicle we'll take as a 2-wheeler, which is petrol fueled. We add that, and the cost of petrol. So it is almost 100 now. So we add that. The average economy of the petrol vehicle. So we have given the mileage of the vehicle. That is the number that we have to add here, which is 40 kilometers per liter for the petrol fueled vehicle, and daily distance that is traveled. So here in case of this, it was I think 15 kilometers. The 2-wheeler is every day travels for 15 kilometers, and it's every day they are using the 2-wheeler. So we said 365 days. Number of days you are using the vehicle in a year, and then average number of family persons traveling together in the vehicle. So 2-wheeler seems to be used by only 1 person. So we write here 1. And average number of persons other than family sharing the vehicle. So there is no such information about for the 2-wheeler. So we say 0 here. And then again you can see some numbers coming here. You just say submit. And then you can see that all this data is here. So we can now add the information for our next vehicle, which is a 4-wheeler, and it is diesel fueled. So diesel, I don't know what is the cost of diesel right now. Consider slightly lesser than petrol. And average economy of the diesel vehicle was 12 kilometers per liter, and daily running is 60 kilometers. So in case of number of days this vehicle is used, maybe it's office vehicle, so we can consider less than 365 days, or you can also consider 365 days if you are using it all year. Then average number of family persons traveling, so that was given as 1, and average number of number of persons other than family. So this information we have that somebody else is also accompanying the person traveling in car. So maybe they are carpooling or something, or so that's why we have added here one, and then just submit. So once you submit here, and if you have mentioned that you are going to add data for 2 or 3 vehicles, you get a pop-up here saying that data has been saved successfully. Just say OK, and then related to the air travel, as I mentioned, that only if you do air travel for a personal or recreational purpose, you have to add that data here. In that case, we have a website here, which will easily give you a number that we need to add in our footprint calculator. So, is this website visible? Is this like I clicked on this page? And
yeah. It's visible.
Okay. So here it's very simple to use this page. You just have to add the data that we have about the family. That it's a round trip. Then there we have given its economy class, and the number of people traveling is all the family members, that is 4, and the to and fro the city. So it's from Pune to Bangalore. In case if you want to check this and you don't have the city here, your to and fro, in that case you can just check the distance that is there, and then see a similar location of the same distance and add that city. Sometimes all the cities are there in this. Hello, am I audible?
Yeah, go on.
Yes, ma'am.
Okay. And then just say compute after adding this information. So here you get to know what is the total passenger CO2 per journey. So this number here, that is 648.1, we will copy this number and we'll add it here in our calculator, where it says that annual carbon emission due to air travel, and it's in kgs. So we simply copy and paste this number here, and then you can add the cost that that you have spent for this travel, and just simply say submit air travel details. Then you get a pop-up saying OK. So now we have added all the data related to this. You can just click here to get to know your carbon footprint. So in this case now, so it's like getting to know your individual footprint as well as family footprint is like the first step towards understanding the impact, like your impact on climate, on the climate change that we are seeing. So here in case of this family, you can see that the family emission is 43 like tons of CO2 equivalent, and when you divide it between the number of family people, it is 10.76 tons of CO2 equivalent. So this is per person, it is 10, and you can see here that what does that mean. Like, so the acceptable like per person emission globally is 2 tons of CO2 equivalent, and people from the developed countries like US, they have around 11 tons of CO2 equivalent, and then you can see the global average, it's 5 tons of CO2 per person, and at India level it is 1.8, but I think this number has increased a bit. So we need to update this, but it is not more than 2 or like more than 3 or something. So at an individual level, if you see the footprint of this family, the per person footprint is 10 tons of CO2 equivalent, which is equivalent to the per person footprint of a developed country. So this is something we need to look at. And then we have a circular representation showing here that which sector is causing the maximum emission. So here in like if you click on these these tabs, you will see which is this. You can see the emission here from each sector. So if you click here, it is about indirect emissions. So for the indirect emissions, as Dr. Garve mentioned, that the house floor area or the carpet area of your house, that and the way you manage your wet waste, organic waste, those are the proxies for calculating indirect emissions. So that is around 12.33 tons. Then the small here is about air transport, which is less, and then the transport related emissions, which is 22.87 tons, and then we have the electricity, and the smallest one is the cooking energy. So it's clearly visible here that the transport sector for this family is causing the maximum footprint. So in case if they want to take some initiatives for reducing their footprint, they can start by using better transport facility, efficient vehicles, or switching to electric vehicles, or maybe not using vehicles wherever it is possible. And related to air travel, it is there is now we have this facility where you can offset your emissions. So a lot of airlines do give you, while you book your air travel, they give you this option that do you want to offset your travel emissions, and if you click on that, you have to pay some extra amount, some 200 or 500, and then that goes to their maybe CSR initiative or some initiative which will further make sure that you are kind of offsetting your emissions by using that facility, by saying yes to that cause. So that's, if you do that, then you can say that you are kind of helping reduce the emissions. Then and the same information is given in the tabular form as well. Only one of the best part about this footprint calculator, or the unique part, is that you also get how much money you are spending on these emissions. So if you have used any other calculators, or if you have come across any other carbon footprint calculators, so the first thing is that you don't end up completing the calculation. And even if you complete the calculation, you are not sure about the accuracy of it. That is one. And the other thing is that nobody really talks about the amount that you're spending on the emissions. So in that case, this calculator will tell you that how much money also you're spending in an entire year for all these in all these sectors. So here you can see for the transport, which is causing the maximum emission, there the family is spending almost 63,000 in a year. So which may not be a lot for the family, but there can be, like, this is, since this is very basic information, there can be someone for whom this matters a lot and can be a motivational factor to reduce the emission. So so it is something to look at as well. And then we have the carbon emissions from each sector here given separately here. You can download this result and keep it for your, like, you can use this as a kind of base emission, and then make some changes in your lifestyle, and then again use the calculator to see how much you have reduced, or what is has it helped. So this is basically like as it is mentioned on the slide also, that you need to measure first in order to understand, do you need to reduce your emissions, or are you at a good level. So we always give the example of a weight loss program. In case if you want to lose weight, or you have to gain weight, you first need to know how much is your weight. So that's what the carbon footprint calculator does for you. It will tell you where do you stand in the first place, and then you can decide what you should be doing, or best part is in which sector you need to take the actions. Mostly otherwise people who say that obviously my footprint will be more only, so let me start planting trees, or let me start going for a walk, like walking, but then you're not sure if are you reducing, or you are not really helping. So in this case this calculator will give you the guideline for leading a low carbon lifestyle. Yeah, that's. Thank you. If you have any questions.